Welcome to the lesson on divisibility of numbers. At the end of this lesson, you will be able to apply tests. Observe these questions. They are pretty simple to answer. If you know your multiplication tables, you can answer them even without doing any division. Now, look at these questions. They involve some very large numbers. How will you answer them? One way, by actually carrying out the division. However, there is another way in which you can answer these questions without doing the lengthy division. These are some simple tests of divisibility that can help you decide whether a given number is divisible by another number. In this lesson, we will learn about the tests of divisibility by the numbers 2, 3, 4, 5, 6, 8, 9, 10, and 11. Let us begin with the test of divisibility of numbers by 2. First, we will look at the multiplication table of 2. The highlighted numbers 2, 4, 6, 8, 10, and 12, and so on, are all multiples of 2. A number is a factor of all its multiples. Thus, all the multiples of 2 are divisible by 2. Now observe the digits in the ones place for all these multiples of 2. They are 0, 2, 4, 6, or 8. This is true for all multiples of 2. Thus, a number that has 0, 2, 4, 6, or 8 in its ones place is divisible by 2. You can use this divisibility test to see if any given number is divisible by 2 or not without actually dividing it. Now, let us look at the test of divisibility of numbers by 3. Let us take a look at the multiplication table of 3. The highlighted numbers are multiples of 3, and hence divisible by 3. Now, look at this interesting pattern. Note that the sum of the digits of each multiple of 3 is also divisible by 3. This is true for all multiples of 3. Thus, if the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Thus, to test the divisibility of a number by 3, find the sum of its digits. If the sum is divisible by 3, only then the given number is divisible by 3. Now, let us look at the divisibility test by the number 4. Every fourth year is a leap year that has 366 days. Another interesting fact is that the number representing a leap year is always divisible by 4. Here is a list of leap years that will occur in the present century. Thus, all these numbers are divisible by 4. Observe the last two digits of these numbers that are divisible by 4. Note that the number formed by the digits in the tens and ones place in each number is divisible by 4. This is the test for divisibility by 4. A number is divisible by 4 if the number formed by its last two digits, that is, ones and tens, is divisible by 4. Thus, to check the divisibility of a number by 4, check if its last two digits are divisible by 4. Let us move on to the divisibility test of a number by 5. Let us take a look at the multiplication table of 5. Note that the digit in the ones place for all the multiples of 5 is either 0 or 5. This is true for all multiples of 5. Thus, a number that has either 0 or 5 in its ones place is divisible by 5. You can use this divisibility check if a given number is divisible by 5 without actually dividing it. Now, let us look at the test for divisibility by 6. Here is the multiplication table of 6. Note that all the multiples of 6 have 0, 2, 4, 6 or 8 in their ones place. Thus, all the numbers divisible by 6 are also divisible by 2. Let us find the sum of the digits of all the multiples of 6 and apply the divisibility test for number 3. Note that all numbers divisible by 6 are also divisible by 3. This is true for all multiples of 6. Thus, a number is divisible by 6 if that number is divisible by both 2 and 3. Thus, to test if a number is divisible by 6, check if it is divisible by both 2 and 3. Now we come to the test of divisibility by the number 8. Here are a few numbers divisible by 8. Do you observe any similarity in these numbers? Observe the number formed by the digits in the hundreds, tens, and ones place in each of these numbers is divisible by 8. This is the test for divisibility by 8. A number is divisible by 8 if the number formed by its last 3 digits is divisible by 8. Thus, to check the divisibility of a number by 8, check if its last 3 digits are divisible by 8. Now, let us look at the test of divisibility of numbers by 9. Look at the multiplication table of 9. The highlighted numbers are multiples of 9, and hence divisible by 9. Now, look at this interesting pattern. Note that the sum of the digits of each multiple of 9 is divisible by 9. Here are some more numbers divisible by 9. Note that the sum of their digits is divisible by 9. Thus, a number is divisible by 9 if the sum of its digits is divisible by 9. Thus, to test divisibility of a number by 9, find the sum of its digits. If the sum of the digits of the given number is divisible by 9, then the number is divisible by 9, otherwise not. Let us move on to the divisibility of numbers by 10. Here is the multiplication table of 10. It is the easiest multiplication table to remember. The highlighted numbers 10, 20, 30, 40, 50, etc. are all multiples of 10, and thus divisible by 10. Now, observe that the digit in the ones place for all these multiples of 10 is 0. This is true for all numbers divisible by 10. Thus, a number that has 0 in its ones place is divisible by 10. Using this divisibility test, you can quickly check if any given number is divisible by 10 or not without actually carrying out the division. This brings us to the test of divisibility of numbers by 11. Here are some numbers that are divisible by 11. These numbers look very different from each other, but follow an interesting pattern. The digits in the numbers can be assigned odd and even positions from right to left as shown here. Observe the digits at the odd and even places in the number 1375. The difference between the sum of the digits at the odd and even places is equal to 0, which is divisible by 11. Consider the number 72,424. The difference between the sum of the digits at the odd and even places is 11, which is divisible by 11. The difference between the sum of the digits at the odd and even places in 728,090 is equal to 22, which is again divisible by 11. This is true for all numbers divisible by 11. If the difference between the sum of the digits at the odd and even places in a given number is either 0 or a multiple of 11, then the given number is divisible by 11. Besides tests of divisibility by specific numbers, there are some general rules of divisibility that apply to all numbers. The first rule states that if a number is divisible by another number, then it is also divisible by all the factors of the other number. For example, 36 is divisible by 12. Thus, by this rule, 36 is also divisible by all the factors of 12, that is, 1, 2, 3, 4, 6, and 12. The second rule states that if two numbers are divisible by another number, then their sum and difference is also divisible by the other number. For example, 45 and 120 are both divisible by 15. Thus, the sum of 45 and 120 is 165, which is divisible by 15. The difference between 120 and 45 is 75, which again is divisible by 15. Before we move on to the next rule, we need to understand the concept of co-prime numbers. By definition, if the only common factor of two numbers is 1, the two numbers are called co-prime numbers. Consider the numbers 8 and 15. When you factorize the numbers, you find that the only common factor of 8 and 15 is 1. Thus, by definition, 8 and 15 are co-prime numbers. Note that neither 8 nor 15 are prime numbers. Thus, a number does not have to be a prime number to be a co-prime with another number. The third rule states that if a number is divisible by two co-prime numbers, then it is also divisible by the product of the two co-prime numbers. For example, 80 is divisible by co-prime numbers 5 and 8. Thus, by this rule, 80 must also be divisible by the product of 5 and 8, that is, 40. This is true. This brings us to the end of the lesson on divisibility of numbers.